Hi, and welcome back to the My Math by McGraw-Hill homework tutorial. I'm Mr. Galvez, and in today's video, we'll be looking at Chapter 12, Geometry, Lesson 7, page 941, lesson titled Three-Dimensional Figures. Yeah. This does turn into a hands-on lesson, and for the hands-on portion, we will need some paper, marking pens, scissors and tape, or scissors and a glue stick, and you'll need your handy and trusty ruler and a small protractor. This is a little protractor I cut out from a piece of paper that I Googled from Google Images. And the protractor is going to help me ensure that my angles are a certain degrees. Okay. Now, in lesson 7, we are going to come across certain vocabulary terms, certain math terminology that I want to review with you very briefly. In the three-dimensional figures, we're gonna find that the figures will have a length and a width and a height. So here's a drawing of a rectangular prism that has a length over here of 6 centimeters long, a width that goes back in space, back in dimension of 4 centimeters, and a height going up of 4 centimeters also. Okay, so this is the length and the width and the height of this figure right here. Three other terms that are to be noted in this lesson are faces, edges, and vertex. Okay, and the faces are the flat planes that make up the figures. Here's a flat face in the front of this figure, and there's a flat one right behind it. There's a flat face to the right side and a flat face to the left side, and then a flat face up here, which you can kind of think of as a roof, and a flat face down here at the bottom, which you can think of as the floor, the base. Okay, and one vertex, and we're gonna have multiple vertex, so we're gonna have vertices, multiple vertices. Here's the edge line. We will have multiple edge lines. Here's a 1, 2, 3, 4 edge lines at the bottom of this figure, 4 edge lines at the top of the figure, 4 and 4, that's 8. Then you also have 4 edge lines coming down from each of those vertice points. So we do have multiple edge lines, multiple flat faces, multiple vertice points. And in this lesson, we will be coming across these prisms in particular. The rectangular prism, the triangular prism, and the cube. In the rectangular prism, we'll see that it's a figure that has at least 2 rectangles in it. The rectangular prism does have 6 faces, 2, 1 in front and 1 in back, 1 on left side, 1 on right side, 1 on top and 1 on bottom. We can count 12 edge lines, and we can count 8 vertice points. In the triangular prism, we're going to have 2 faces that are in the shape of a triangle. We're also going to have 3 more flat faces that are in the shape of rectangles, or it could be a square. They could be squares. We will be able to count 5 faces. We will be able to count 9 edges, 9 edge lines, and also 6 vertice points. And the cube, which we had constructed in the prior lesson, is a 3-dimensional figure that's composed of 6 square faces, 1 in front, 1 in back, 1 on left side, 1 on right side, 1 on top and 1 on bottom. We do have 12 edge lines, and we also have 8 vertice points, just as in the rectangular prism. Just as that, it's just the only major difference is that we're working with square faces all the way around. Here is that cube that we made in an earlier lesson. This one turned out to be I believe, Bob's Bob's Shop of Nightlights. Okay. Um, Here's a rectangular prism that we constructed earlier. And each one of these black marks can be thought of as an edge line. You can think of this as the length, the width going back, and the height going up. Okay. Now, for today's lesson, we're going to work together to create a triangular prism. Okay, and here's one way that I like to quickly make a triangular prism. It not so quick as in we'll get this done in a few seconds, but do bear with me as we work to create this prism. Okay, I do want to start with a rectangle, a rectangle, and I'm going to do my best to make a rectangle square. I'll make this rectangle go from 0 to 5. It'll be 5 inches long. Actually, I'm going to work with centimeters on this one. So let me go from 0 to 14. 14 centimeters long. I do need some square lines. So here's where I get that protractor. I'm going to make my 90-degree angles. 90-degree angle over there. 90-degree angle over here. And then for this rectangle, I think I'll go up 4 centimeters. Okay, just because the paper is not super large. 4 centimeters. Let me connect those endpoints at 4 centimeters. Okay, so I'm going to start with the rectangle, and I'm going to work from that. I'm going to use this rectangle to construct this net, or a net similar to this. This net is a 2-dimensional figure that is used to create a 3-dimensional figure. Here we have some rectangles. I'm going to probably kind of duplicate these series of 3 rectangles. And then over here is another rectangle, but I'm going to turn this into a triangle instead on this assignment. This will also turn into a triangle, and then we're going to wind up not using this space over here at all. Okay, so this is a net from a prior lesson. For this triangular prism, one trick I do want to show you is that this rectangle must be divided in half. And I'll explain in a second why. So if this is 4 centimeters, I'm going to give me a little mark at 2 centimeters. Then I'm going to put a mark. I'm going to do a line all the way across, which is going to be used to help me create some triangles. A triangle on the left side and a triangle on the right side. Okay, make that line sort of thin. And now for the triangle, here's where I get to decide how long the triangle needs to be from this vertice point to create a new vertice point. And for this triangle, I'll go ahead and make it an even 4 centimeters. Okay. So if I'm going to do 4 centimeters over here, I need to do the same over here and make this 4 centimeters. And I also want to have this congruent triangle on this side. Congruent, same size, same shape, same dimensions, same measurements. 4 centimeters over here. 4 centimeters on the opposite side. So that I have 2 pairs of opposite congruent triangles. Okay. Now I need 2 more rectangles here that are going to connect to this side of this triangle and this side of the triangle. Now, if this measures 4 centimeters, this rectangle over here also has to measure 4 centimeters. 4 centimeters. This line here is going to connect to another line over here. And if this line is 4 centimeters, this line also has to be 4 centimeters. I'm going to go from 8 to 12 to create the 4 centimeters. Okay, connect that. Connect this. On the opposite side, I'll need the same thing, 4 centimeters. Since this triangle edge line over here is 4 centimeters, I need this over here to be 4 centimeters. And I definitely want to use the straightest line I can create, 6, 7, 8, 9, 10. From 6 to 10 is 4 centimeters. And up here, I'm going to go from 8 to 12 for my 4 centimeter measure. Now I connect these over here, these top lines up here, endpoint to endpoint, connect those. And last but not least, my last edge line is over here. Okay, and what's going to happen is that this edge line at the top and at the bottom are going to wind up meeting. Okay, this edge line on this side and this edge line on this triangle are going to wind up meeting. Now, to help, so I'm going to cut this net out. Here's a net of a triangular prism. I'm going to cut it out. I'm going to fold it along these black lines, along these edge lines. But to help keep it together, to help attach it to itself, I'm going to create some tabs. I'm going to cut around this. Glue stick can go here, and this will wind up folding around and gluing to this edge over here. Okay, I'm going to have also this tab that I will not cut out is going to wind up being glued to here, and I need one over here, a tab over here that I won't cut out. I'm going to keep it attached to that. Winds up being glued over here. Same thing with the opposite side over here. I'll create my little tabs. This gets glue stick or tape. And I'm going to cut this all the way around. I will not cut along these lines at all. I'm basically going to cut around the outside of this net. I'm going to fold around and fold along each line. And once everything is folded around, I tape things around. And we wind up creating this triangular prism. Okay, this is one I made earlier just to save time. This one wound up measuring, I believe, 10 centimeters in length. This measures 4 centimeters. And this triangle here has an equal, congruent triangle on the opposite end. So here's my small collection of three-dimensional shapes, three-dimensional figures. In the lesson, if we count each one of these faces for the triangular prism, let's see how many we count. 1, 2, 3, 4, and 5. I think those are all counted. I have 5 faces, 5 flat faces. 2 of the faces are congruent triangles. 3 of the faces are rectangles. I'm not sure if they're congruent. I don't think they are, but I think face 1 and face 2 are. I'm sorry, face 1 and face 3 look congruent. This face number 2 is a rectangle, but I don't think it's congruent to the other 2. It looks kind of wider. Actually, a matter of fact, if I measure right here, this measures 5 centimeters on point. However, this measures 4 centimeters exactly. So the face 1 and face 2 are not congruent. We do have edge lines here, 1, 2, 3. On the opposite side, we have also 1, 2, 3, 6 total. Then we also have 7, 8, 9 edge lines on this triangular prism. And last but not least, for the vertice points, we have 1, 2, 3 on this side. These little points, 1, 2, 3, 1, 2, 3 on the opposite side, 6 vertice points. So there you have it. If you can create this triangular prism, take your time. I did go through a bunch of paper, but you just practice and keep at it, and you should have fun with this lesson. Okay, I hope you enjoyed. See you soon. Thank you for tuning in. Bye bye.